Hello everyone and welcome to the third workshop of the free Java bootcamp, and today we are discussing variables and data types in Java. The goal of this workshop today is to understand what variables are, to understand what data types are, and we're going to discuss a little bit of computer architecture or computer systems just to understand what is happening under the hood when you are writing code and declaring variable in your code. So let's get started. What really are variables? A good analogy I like to use to describe where the way variables are is that a variable is like a cup. Think of it like a glass of water. You can pour some water inside, and you can pour some juice inside, you can pour something in the cup. That cup is a container designed to contain a certain value. And a type of container might be designed to contain only a specific type of value, a specific volume of value. So that's what variables are. Let's look at some example in code. Here we have a basic Java program, and you can look at this line 5 here. Line 5 has, for example, int x is equal to 20. X here is a variable that contains the value 20. So I can change it to 21 or 22. That's why it's called a variable. I can change it to any other number here, for example. String name is John. The name here is a variable that has the value John. So I could use another string and it still works as that. So we're going to discuss a bit of the computer architecture, like I said, where we will see a bit in depth what's happening in the computer when you are defining these variables, writing these lines of code. So what are data types? Data types are the contents. In our cup analogy, we said we have a cup, which is a variable, and the content is juice. Data type can be water, juice, and so on. The data types are the type of things that you put in those variables. And we're going to look at again at our little code base here. And here you have int x is 22. Int here represent the data type. We're saying this variable is designed to contain values of type integer, and the value here is 22. So you can only put an integer here. Imagine I try to put like 0.9. You have my ID underlining it saying, oh, something is wrong. You are trying to put a double inside an integer. So we're going to look at the various data types available in Java right away and see what are the implications here. So in Java, there are two categories of data types. We have the primitive data types and the non-primitive data types. The primitive data types are Boolean, characters, integer, and floating point numbers. So Boolean is true or false. Character is a single letter of the alphabet or a single character. Integer is a number, a whole number, and it can have different lengths depending on how long the number is. And float are numbers with decimal places like 17.9 or when you have a point. So floats have two reserved words for creating them, float and double. Non-primitive data types include types that are a mixture of these primitive data types. For example, string is a mixture of characters. It's multiple characters that form one string. So if you have a name John, J in this name John is a single character. I can create a variable car letter and save the letter J in there. And in Java, characters have single quotes. The entire string here is represented with double quotes. It has many characters. Here, this one can take just a single character. If I try to put more than one character, there's a problem. It tells me, no, you are putting too many characters for a string literal. So that's it. Now, let's discuss a little bit the computer architecture and why these things exist. The reason why I put this section is really to discuss why are they integers, why are they doubles, why can't I just create variables anyhow, why do I have to specify the data type of the variable in Java. So in your computer, when you are creating a variable, you're actually keeping it in temporal memory called the RAM. This is the main memory of the computer, and this is the memory that the computer's processor accesses when doing operations. So that cup where you're trying to save your juice is actually in the RAM. So every RAM is divided into addresses and slots, and we don't need to get into those details. But every time I say int x is equal to 20, what I'm telling my computer to do is that I'm saying create some space inside the RAM where you are going to store the value 20 and call that space x. So that every time I mean x, you are going to that space in the RAM to get me whatever value is saved in that space. Secondary storage, for example, is the hard drive. That's not where variables are saved during execution of a program, right? So remember that at the basic electronics level, everything is electricity, everything is current. Presence or absence of current represented as ones and zeros. So we are talking about bits, ones and zeros, that all data ends up being represented as. How do you represent the number 2 in binary? 2 in binary will be 1, 0, for example. How will you represent the letter A in binary? So we have to come up with a scheme for representing characters and different kinds of data in that same ones and zero representation. In order to represent letters in computer systems, humans had to come up with a scheme. And one of those schemes, for example, is the ASCII table. ASCII is a way to encode letters into binary. So if I want to represent the letter A in this case will be given the code 65. This capital A will be given the code 65, which is expressed in binary as what you have here, 01000001. And that is the binary code for letter A. But remember that you can represent either letter A or number 65. How does the computer know that now I'm talking about the letter A or I'm talking about the number 65? Because they're going to have this exact same binary code. That is why you need data types. In the number of bits that pass on this bus, there are some other bits that are going to help the computer know this binary string we're talking about here is a number. This binary string we're talking about here is a letter. So don't convert it to 65, convert it to A, for example. Don't convert it to 97, convert it to small a. And this is just a short form of the table. There are so many other things, non-writable characters and even emojis and stuff like that nowadays have some representation, especially in other languages where you have complex characters like in Chinese and so on. So there are other ways of representing. This is just a basic way to illustrate the concept here. That's where data types come from. So in programming, when you are writing an instruction like car letter is equal to J, you are telling your computer, create some memory in the RAM where I'm going to save the letter J. But this capital J is going to be converted to its equivalent in binary, which is 74 here, and 74 is going to be represented in binary along with some other data that tells us the computer that here we're talking about the letter J and not the number 74. So that's really what we're trying to explain here. In summary, you have to remember everything in a computer is ones and zeros. And variables and data types help us save these ones and zeros. Variables help us save them, and the types help us know which ones and zeros we are talking about. Before we end this session, I'm going to mention one more trick that came later on in the Java language, which is a keyword called var. So var allows me to create a variable that has different types. So in this case, I'm telling my computer to deduce the type of this variable based on this value here. So in the Java language nowadays, I can say var z is 12, and then my computer will know, oh, in that case, z here is an integer, of course. So if you look at it here, you can see that it's int. Now I can say this var here is good, and now it's going to know, oh, in this case, then we are talking about a string good. So the same variable, without me having to specify these types explicitly, the computer can, in a smart way, deduce what type I'm trying to infer. But know that under the hood, the computer always has to know what type it is dealing with, because it's binary and it can't get mixed up on the types. So that was just a bonus tip for the moment, something recently added to Java. I hope that this was helpful, and see you in our next workshop.